Hello everyone. In this brief lecture, we will discuss about carbon and nitrogen dynamics in conservation agriculture. So all of you might have aware that most of the scientists nowadays they are suggesting to go for conservation agriculture instead of conventional agriculture. So why they are suggesting so? Uh, what is the advantages of conservation agriculture? How it is being evolved? What is the effect of this conservation agriculture on soil quality, most importantly carbon and nitrogen dynamics, because they are the most determining factor of soil health and soil quality, this carbon and nitrogen, from the crop growth perspective, from the soil perspective as well. So we will discuss this lecture series with the heading of what is conservation agriculture and how it is evolved, scope of conservation agriculture, advantages and limitations of conservation agriculture, what are the conservation agriculture practices, role and dynamics of carbon in the soil, conservation agriculture and carbon dynamics, nitrogen dynamics in soil, conservation agriculture and nitrogen dynamics, and we will conclude the slide. So you will learn a lot of things, lot of concepts, lot of facts in this brief lecture. So do not miss this lecture. So what is conservation agriculture? What is this conservation agriculture? According to FAO, that is Food and Agricultural Organization, Food and Agricultural Organization. This is the headquarters is situated in Rome, and it was established in 1945, 16th October to be precise, 16th October 1945, and 16th October is also known as World Food Day is celebrated in this day. World Food Day celebrated on 16th October. Okay, so according to FAO, that is Food and Agricultural Organization, it is a concept of resource saving agricultural crop production which is based on enhancing natural and biological processes above and below ground. So what FAO defined conservation agriculture, that in conservation agriculture we are basically conserving the resources. What are the resources available in the farm? We are basically trying to conserve that, and simultaneously we are raising the crops and we are enhancing the natural and biological processes above the ground as well as below the ground. So why it is necessary to conserve these natural resources and the quality or enhance the natural and biological processes above and below the ground? Because crop environment, it consists of, suppose this is a crop, this is the root system and this is the canopy. Crop environment consists of both above ground and below ground ecosystem. Okay, so we need to maintain both the biological processes above and below ground for the crop sustenance. What is conservation agriculture? In conservation agriculture, we are basically trying to conserve the resources. Okay, so what we are trying to do here, mostly in conservation agriculture, we are remaining we are not completely tilling the soil, or we are not completely disturbing the soil. Rather, we are just conserving the soil health by maintaining the residue over the ground. Okay, at least we should place 30% of the crop residue as such in a farm or in a field. Okay, so what will happen? It will restrict the wind and water erosion in the field, and it will increase the organic carbon content in the soil and increase the microbial activity in the soil, so that soil health will be maintained. So how it evolved, how this conservation agriculture practices evolved? History repeats itself. Initially, when people started the agriculture activity, there was no tillage. Okay, tillage was not invented at that time. Okay, so first Jethro Tull, he invented different tillage implement, and he is also known as father of tillage, and he has written the book also, Horse Hoeing Husbandry. So he first proposed that after tillage our crop productivity enhances. Okay, so then tillage implements being developed, like primary tillage, secondary tillage implements being developed, and people started tilling the soil for better productivity, and there was significant increase in productivity as well due to tillage. Then gradually there were heavy implements used for tillage activity. Then what happens? The soil physical structure deteriorated, the quality or health of the soil degraded. So people or scientists recommended conservation agriculture approach or conservation tillage approach. There we are again minimizing the tillage activity. So history, that's why it is being told, history repeats itself from initial no till system to now limited tillage system. So this is the cycle. Edward H. Faulkner, he is also known as the father of conservation tillage. Who is the father of conservation tillage? Edward H. Faulkner. He has written a book called Plowman's Folly, and in that book he has mentioned what are the negative or drawbacks of continuous tillage. In 1930s, there was development of dust bowl due to extensive tillage in USA. Okay, in 1940s, most of the selective organic herbicides were invented, and they are being used after the invention of different, after the manufacturing of different organic selective herbicides. We could replace the weed management from tillage activity or mechanical manipulation from the herbicide application. So that was a push for a conservation tillage activity. In 1970, there was steep rise in oil price in the USA. So the tillage implement we are using basically that needs different fossil fuels. So as the fossil fuel price increased during 1970s, the people started using less tillage implements in that particular time. So all these are driving a tool for conservation tillage approach. Okay, and in 1990s there was a no seed till drill, that is happy seeder and turbo seeder, they are being manufactured. So basically in conservation tillage what we are doing, basically in a field we are maintaining the residue up to 30%. Okay, and there how we will sow the seed. Okay, for that there was development of no till seed drill, that is happy seeder and turbo seeder. They directly place the seed in the even if in the residue situation, even if there is residue in the field, they can place the seed at a certain depth, that is turbo seeder and happy seeder. Then you must be asking that how weeds can be controlled. So we can apply herbicide. Here we are not disturbing the soil much, but we can apply different agrochemical to control weeds or any insect. We can apply different agrochemical. Currently around 180 million hectare global area is under conservation agriculture, and in India around 3.2 million hectare is under conservation agriculture. Mostly conservation agriculture in India is confined to Indo-Gangetic plain in rice wheat cropping system. Okay, so how it is evolved, the conservation agriculture? Initially no till planting, then plow share, waste shaped implements developed, then MB plow was developed, then dust bowl, then rise in oil price. It led to minimum tillage or modern approaches of tillage like minimum tillage, zero tillage, conservation tillage. Then also that was pushed by happy seeder, turbo seeder manufacturing. So this was the driving tool for conservation agriculture or evolution of conservation agriculture. What is the scope of conservation agriculture? Initially, due to intensive tillage or non-judicious resource application, the partial factor productivity that declined. Soil health also decreased. Yield stagnation was recorded. Increase in soil erosion as well as soil pollution happened. Higher greenhouse gas emission happen. So if we are indiscriminately using the different resources in agriculture, so these are the major problems we are facing from the agricultural activity. So at the initial 1970s there was green revolution. What was the driving tool for green revolution? The high yielding varieties, mostly wheat varieties, then fertilizer. These high yielding varieties, they are fertilizer responsive, and they are also responsive to irrigation. Okay, so due to irrigation facility, due to more fertilizer application, and due to use of high yielding variety, there was green revolution achieved during 1970s. Okay, significant increase in food grain production happened that time. But this green revolution led to different green revolution related problems like multi-nutrient deficiency. Now we are finding several multi-nutrient like micronutrient deficiency and macronutrient deficiency throughout the India and globally also. Mostly in India, which macronutrient is mostly deficient? Nitrogen and sulfur. Which micronutrient is mostly deficient? Zinc and iron. Okay, boron in some cases, somewhere it is like cobalt, or mostly zinc and iron. Okay, so this is multi-nutrient deficiency. Then herbicide and pesticide resistant crops and weed biotype has been developed because we are continuously using different agrochemicals in the field, different plant protection chemical, which lead to resistance development. Then greenhouse gas emission, as we are using more nitrogenous fertilizer, there is more emission of nitrous oxide. As we are using more submergence in rice, if we are cultivating more and more rice, then there is more and more submergence, so it will emit methane, nitrous oxide, methane. These are called greenhouse gases. Why they are called greenhouse gases? Because they can trap the solar radiation for longer time and more efficiently. Okay, then soil health degradation due to continuous tillage, due to residue removal, due to application of different agrochemicals, synthetic agrochemicals, there is soil health degradation, and due to soil health degradation there is yield stagnation, decrease in yield. These consequences are there. So these are the scope of conservation agriculture. We need conservation agriculture right now to sustain our future crop productivity. What are the advantages and limitations of conservation agriculture? You can answer yourself. So what are the advantages or benefits of conservation agriculture? Basically, we can, by conservation agriculture, we can build soil organic carbon. So as we till the soil, the carbon present in the soil that convert into carbon dioxide and it releases into the atmosphere. But if we are maintaining the residue in the soil, that will add carbon, because in most of the residue 40 to 45% is carbon. Okay, so if we are adding residue to the soil, then that will add carbon to the soil, and carbon is the energy source for different microbes. So as the carbon enrichment will be there in soil, there will be more microbial growth, and microbes are they are helpful for different nutrient cycling, different different toxic and degradation, etc. So that is necessary. Then they sequester greenhouse gas. So sequestration means we are just converting the atmospheric carbon dioxide pool or carbon pool to the terrestrial carbon pool. That is sequestration. Will come later on. Then timely planting increases 8 to 10 quintal per hectare wheat yield. So basically the major problem in rice wheat cropping system in basically Indo-Gangetic plain, what is the major problem? The late sowing of wheat, because after harvesting of rice, the straw management is a bigger problem in the Indo-Gangetic plain. So after removing all the straw, again there is cultivation needed, then again wheat is sown, so there is a time gap needed. Okay, so by converting that conventional farming to conservation agriculture or conservation tillage approach, we are basically using the happy seeder, turbo seeder to directly place the wheat seed in the residue situation as well. Okay, so basically we are harvesting the rice crop and we are just letting the rice straw in the ground to present. Then we can go for even seeding or sowing by using happy seeder or turbo seeder in that residue plot. Okay, so there is a time gap we had certain. Okay, due to shortening of time gap, there is more increasing in the wheat yield we can observe. Okay, then less diesel consumption, reduced cost and greenhouse gas emission we can have. Then water saving is up to 15 to 50%, reduction in weed population is up to 50 to 60%, and soil biodiversity is also increased. So these are the benefits of conservation agriculture we can record. Then limitations of conservation agriculture: highly machine dependent. Okay, we have to depend on happy seeder and turbo seeder. There's very minimal quantity of or very limited number of resources or implements are available for the sowing activity in a conservation agriculture area. Then availability and handling of crop residue is a major problem. More perennial weed infestation. If we are going for conservation agriculture approach, there will be more perennial weeds will come up, and to manage that perennial weeds is a daunting task. Then complex interaction between tillage, residue and herbicide. So as there is more residue present in conservation agriculture, there is more complex interaction you can find. Immobilization due to priming effect. What is priming effect? Whenever we are adding certain fresh residue in the soil, that fresh residue contain higher amount of organic carbon. So to consume that organic carbon, more number of microbes will grow there. Okay, are you getting my point? If food availability is more, then there will be more microbe or insect attack will be there, or fungal attack will be there, because food is more available. Like that, in soil, carbon is the food for different microbes. As the fresh organic matter we are adding, it contains more carbon, so there will be more increase or rapid increase in different microbial activity surrounding to that fresh residue. That microbes, rapid increase in microbial growth or microbial population, they will trap the available nitrogen that is present in nitrate form and ammoniacal form, mostly nitrate form, that will be bind or that will be fixed in these microbes. Okay, that process is known as priming effect. Then allelopathic effect, as there will be more residue, they will have certain allelopathic effect on the next crop. Then technical know-how, we should know or we should train the farmers how to go for different type of cultivation in conservation agriculture approaches, because that is new concept for the farmers. So these are certain limitations of conservation agriculture. Then conservation agriculture practices, there are several practices of conservation agriculture. I am highlighting few of them in this slide. One is laser land leveling. Basically it is a micro leveler and based on the principle of laser reflectance. So laser land leveler, it can enhance the yield up to 10 to 20%. It can save water up to 35 to 45%. It can increase nutrient use efficiency up to 15 to 25%, and it can increase cultivated area up to 3 to 6%. Then zero tillage implements like turbo seeder, happy seeder, we have already talked about. These are the zero tillage implement. It can advance the wheat sowing by 7 to 10 days. It can save irrigation water up to 15 to 20%. It can get yield advantages up to 15 to 20%. Reduction in cost of cultivation around 25 to 3,000 per hectare. And it can reduce terminal heat stress by 6.5% in wheat. Other conservation agriculture practices like bed planting, you can see the advantages of bed planting. Then direct seeded rice, it is also using less water. Then brown manuring. What is brown manuring? There are different type of manuring. What is manuring? Manuring means conversion of a complex organic fresh organic matter to simpler form or a decomposed product. That is manuring. What is green manuring? Green manuring means we are mostly in the crop field itself, we are sowing dhoincha or son hemp or different green manure crops, and at the tinder stage, before there is increase in CN ratio, before there is increase in lignin content in the plant, mostly before the flowering stage, it should be incorporated in the field. Okay, what is green leaf manuring? Green leaf manuring means the legume crop that is being grown outside anywhere else, and we are basically removing the canopy part and we are incorporating in our crop field. That is green leaf manuring. What is brown manuring? In brown manuring, we are broadcasting the dhoincha seed or green manure crop seed in the rice field, and after 20 to 25 days, we are just applying a selective, broadleaf killer, that is 2,4-D ethyl or bispirbac sodium in the field, so that will desiccate the green manure crop. So this is brown manuring. So these are also some of the conservation agriculture practices. Let's discuss about carbon pool and dynamics in the soil. There are different carbon pool present in the biosphere or in the earth, that is biospheric carbon pool, atmospheric carbon pool, atmospheric, hydrospheric carbon pool, then terrestrial carbon pool. There are different carbon pool. They basically, carbon is the mainstay of soil health. It is the mainstay of soil health. It is the mainstay of life as well, because without carbon there will be no food, there will be no energy, there will be nothing in the earth. Okay, so carbon is the mainstay of soil health. Soil acts both source and sink for carbon. How it can act as both source and sink? Because from soil there is respiration and it releases carbon dioxide to the atmosphere, so that is a source. And how it can be a sink? Because it can help, it can it has certain, if we are adding any residue to the soil, then it decomposes and it will remain in the soil itself. So that is a sink. So it can store the organic carbon as well. So this is soil acts as both source and sink for carbon. And the soil organic matter affects the soil physical, chemical and biological property as well. Global carbon cycle is the exchange of carbon among different carbon pools, that is soil carbon pool, atmospheric carbon pool, ocean carbon pool and biospheric carbon pool. Okay, so total organic carbon, it affects everything, the total soil health, basically the chemical health, what it affects, the pH, cations, immobilization of pollutants, it binds heavy metals. Then biological, it provides energy for the biological processes. A large store of different nutrients is stored in organic matter like nitrogen, phosphorus, sulfur, potassium, calcium, copper, zinc, etc. It improves the soil resilience. In physical structure, it improves soil structure, it improves the water retention, it improves the soil temperature. Okay, so basically, if we see carbon dynamics in the soil, carbon stock in soil consists of soil organic carbon, soil inorganic carbon and total carbon. Soil organic carbon means whenever we are adding any residue or any dead organism present in the soil or incorporated in the soil, that is soil organic carbon, because it is in organic form. Then soil inorganic carbon like calcium carbonate, different inorganic form of carbon, that means in mineral form, if there is any carbon present, then that is called soil inorganic carbon. Then total carbon consists of all this carbon altogether. Out of this total global carbon, that is amounted to be 2500 picogram, total amount of soil organic carbon and soil inorganic carbon is 1550 picogram, among which 950 picogram present in the top 1 meter soil, which takes part in soil carbon dynamics. Remember this, total global carbon is 2500 picogram. From this 1550 picogram is soil organic and soil inorganic carbon. Okay, and from this 1550 picogram, 950 picogram, it present only in top 1 meter topsoil. So most of the nutrient cycling and most of the carbon cycle that happens in the top 1 meter soil depth. So that is very important. Conversion of natural system to agroecosystem depletes soil organic carbon, because we are continuously tilling the soil, we are manipulating the soil, so there is loss of carbon from soil organic matter to atmosphere as carbon dioxide. Then when output of carbon exceeds the input, when we are not adding enough carbon or enough residue in the soil but output is higher, that means soil respiration is higher, then there is soil degradation and nutrient depletion from soil profile happens. Okay, soil organic carbon loss from soil is either through carbon dioxide or through methane, whereas soil inorganic carbon loss is mainly through carbon dioxide. Zero tillage basically protects the soil organic carbon from microbial degradation, because it holds the soil organic carbon in the complex. Okay, so there will be more accumulation of soil organic carbon due to zero tillage. Crop diversification increase system crop biomass, different quality like CN ratio, lignin content of residue input promotes formation of complex structure and restrict the decomposition. If we are adding more organic matter to the soil and we are diversifying the crop in the field, then it will store the soil carbon for longer period. Okay, then carbon sequestration, we have already discussed what is carbon sequestration. Basically the conversion of atmospheric carbon pool to the soil carbon pool or terrestrial carbon pool, that is called carbon sequestration. What is carbon trading? Carbon trading is a new concept where the developed nation, they are actually emitting a huge quantity of carbon dioxide or greenhouse gas to the atmosphere. So basically they are promoting to the developing countries or underdeveloped nation to plant different trees by which those developing nations or underdeveloped nation, they can sequester the carbon dioxide, and for that unit amount of carbon dioxide sequestration, they will pay, this developed nation will pay some credit. Okay, that is basically called carbon credit. Then factors affecting soil organic carbon pool. What are the factors affecting soil organic carbon pool and how it changes? Degree of soil organic carbon dynamics depends on the rate of residue addition, how much residue we are adding and what frequency we are adding the residue in the soil. Then climate. If the climate is tropical climate, then the degradation process is more, there will be less organic carbon. If there is temperate climate, the temperature is less, then the degradation process is very slow, then there will be more accumulation of organic carbon. Then soil texture, structure, residue quality, management factor, all these affect the soil organic carbon pool, right? So these are, you can find different factors and different effects of soil organic carbon on the properties of the soil. The nitrogen dynamics and transformation. What are the roles of nitrogen? Nitrogen you can find in protein. There is nitrogen. Protein consists of amino acid, and amino acid the group is amine, that is NH2. So there is a nitrogen, there is a major constituent. Then our nucleotide, that is the basic hereditary material, RNA, DNA, that consists of also nitrogen. Okay, so and our plant, the chlorophyll molecule, that is also that consists nitrogen is a constituent of chlorophyll molecule as well. So nitrogen has again second most important role after carbon. We can say that nitrogen is the second most mineral nutrient or second most nutrient after carbon, okay, for which life is existing in this earth. So due to nitrogen deficiency, there is mostly chlorosis happen, that is the basically the degradation of chlorophyll molecule, and plant looks yellow. There are different, why we are concerned about nitrogen. Nitrogen is basically available to plant in the form of nitrate, NO3 2- and ammoniacal form, NH4+. So this nitrogen, NO3 2-, that is prone to different type of losses like leaching loss, then denitrification loss, then ammoniacal nitrogen, that is prone to ammonium volatilization loss. So what is leaching loss? Leaching loss means this nitrate nitrogen that is more soluble in the water. So in the percolated water, if it is mixed, then that will reach to the groundwater and it will contaminate the groundwater. The nitrate level in the groundwater will be higher, and whenever we are consuming that groundwater, then we might face several problems like blue baby syndrome, like methanoglobinemia. So we can observe those syndromes also. Then there is denitrification loss. Denitrification means if nitrate the nitrogen present in nitrate form and there is submergence of water, then this terminal oxygen present in the nitrate, that will be consumed by microbes, because after the submergence there will be very less amount of oxygen present in the soil. So that microbes present in the soil, they will trap this oxygen, terminal oxygen from the nitrate nitrogen, and this nitrate nitrogen will convert to N2, NO, N2O, and it will release to the atmosphere. So that is basically denitrification loss. Then volatilization loss, that is mainly found in ammonia, NH4+. What happens if there is alkaline condition and if there is more temperature of the soil, then there will be volatilization loss. How it happens? Alkaline condition means OH will be more prevalent. NH4+, from here one H+ will come and it will attach to the OH- and it will form H2O, and what left? NH3. NH3 is ammonia gas, so that will release to the atmosphere. Okay. Then what is nitrogen mineralization and what is nitrogen immobilization? Mineralization means conversion of complex organic nitrogen to inorganic nitrogen. That means organic nitrogen means protein, let's say protein. That is one organic nitrogen. Inorganic nitrogen means NO3 2-, NH4+. These are inorganic nitrogen. So how this organic nitrogen converts to inorganic nitrogen, that is called mineralization. Okay. So how it converts? Due to nitrification process. First aminization, where this protein converts to amino acid, aminization. Then ammonification, that amino acid that converts to ammonium. And then nitrification, where the bacteria used is Nitrosomonas and Nitrobacter. Then finally it will convert to nitrate. Okay. Then immobilization. What is immobilization? That is the conversion of this inorganic nitrogen to organic form. So basically when we consume different nitrogenous food material, if the living organism or microbes, they consume the nitrogen present in the soil, then that is assimilated in its body. So that is basically the immobilization process. So what is the CN ratio and what is the role of CN ratio in nitrogen mineralization and immobilization? CN ratio, basically it is constant for different soil type, and for most of the soil it is basically vary from 8:1 to 15:1, and If the CN ratio is high, that means if the CN ratio is more than 30:1, then there will be immobilization loss. If the CN ratio of the soil is less than 20:1, then there will be mineralization of the nitrogen. Then what is priming effect? We have already discussed. When we are adding fresh organic matter to the soil, there will be rapid increase in the soil microbes, because we are adding more carbon to the soil, more energy material to the soil. So that rapid increase in soil microbe, that is called priming effect. So how we can manage the nitrogen to check the losses in the soil? We have to follow 4R stewardship, that is right time, right place, right manner and right source. Okay, we have to apply right place, right manner, right quantity and right source we have to apply in the soil. Then we can apply slow release nitrogen fertilizer like DCD, IBDU, isobutyl diurea, diamide. These are slow release nitrogen fertilizer. Then we can add we can apply nitrification inhibitor like Na, then AM. These are nitrification inhibitor. We can use different implements like leaf color charts, pad, then green seeker to schedule nitrogen. We should not go for one time application of nitrogen. We should go for split application of nitrogen. Then we can use neem coated urea, briquette urea to increase the efficiency of nitrogen in the soil or in the field. Then carbon and conservation agriculture and nitrogen dynamics. Nitrogen dynamics in soil mainly governed by microbial processes like mineralization, immobilization, and physical processes like sorption, desorption, dissolution, precipitation, chemical processes like oxidation and reduction. So these processes, they basically involved in the nitrogen dynamics. When we adopt conservation agriculture, okay, when we adopt conservation agriculture, we are basically maintaining the residue in the soil, so that will have a priming effect. Okay, initially there will be immobilization effect and there will be deficiency of nitrogen in the field. So we have to, when we are converting one conventional agriculture farm to conservation agriculture farm, initially we have to add more and more nitrogen, about 25% or 30% more extra nitrogen we have to add, because there will be initially immobilization will happen. After few years there will be the balance will happen in the soil, the nitrogen balance will happen. Residue incorporation in soil can fasten the decomposition rate up to 1.5 to 3 times than surface place. If we are applying the soil as residue as mulch, and in other hand we are applying the residue as incorporation, then in incorporation there will be 1.5 to 3 times more degradation of the faster degradation of the residue, because there is more soil and residue contact will be there. Due to proper contact, there will be more microbial growth and there will be rapid degradation. When output of carbon exceeds the input, soil degradation, we have already covered. The crop diversity and residue management increase the nutrient soil profile, soil organic carbon and nitrogen dynamic nutrition distribution mainly confined to 5 to 10 centimeter soil profile. So we cannot let the soil to erode, because most of the fertile soil or carbon and nitrogen dynamics that happens within that top soil or within that furrow slides. The net mineralization and immobilization of soil nitrogen depends mostly in carbon and nitrogen ratio. We have already studied that if we are adding one residue and it has the value more than 30:1, the CN ratio value, then there will be immobilization. If the value of the CN ratio is less than 20:1, then there will be mineralization. Adaptive nitrogen management, conservation agriculture using 4R, right source, right time, right rate and right place, we have to follow. And modern precision management tool like chlorophyll or SPAD based or green seeker based or LCC based, nutrient export based, BRT applicator, fertigation, slow release nitrogen fertilizer and nitrification inhibitor we can use to limit the nitrogenous fertilizer use and to schedule the nitrogen fertilizer, so that we can decrease the different losses of nitrogen in the field. Then what should be our conclusion from this slide? Conservation agriculture comprises of resource saving technique and follow the 3 principles. What are the 3 basic principles of conservation agriculture? One is minimum soil disturbance. As much as possible we should minimize the soil disturbance. Then permanent organic soil cover, basically we have to cover the soil so that we can restrict the soil to expose to different losses. Then diversified crop rotation. We should not go for a single type of crop. We should go for diversification of crops, so that what will happen, there will be more microbial growth, there will be more nutrient dynamics will happen, and there will be less resistance weed and resistance pest will be evolved, because there will be a break of pest cycle or weed cycle. Carbon play the key role in maintaining soil health and sustainable crop production, because carbon is the sole source of energy for different microbes in the soil, and microbes play a significant role in different nutrient dynamics in the soil. So carbon is essential for microbes and for our sustainability, soil sustainability. Carbon sequestration through residue incorporation in soil, mainly in tropical soil, has huge potential to maintain the soil health. Basically, in tropical soil, due to high temperature, due to high water, there is less carbon present in the soil. So it has a potential, and it has a scope in tropical soil to increase the carbon contained in the soil due to carbon sequestration and due to residue incorporation. Nitrogen is the most widely deficient nutrient in India and prone to different type of losses, like we have discussed, like leaching, denitrification, and immobilization. Ammonium volatilization. So we have to check these different losses using 4R stewardship, using different nitrogen management aspect, right? So conservation agriculture is basically a holistic resource conservation approach, and that is important for carbon sequestration, maintaining soil health, enriching soil nitrogen dynamics, and sustainable food grain production, and feed the ever increasing global population. So this is a brief discussion about carbon and nitrogen dynamics in conservation agriculture. If you have any doubt from this session, you can ask me in the comment section. If you have any doubt from any other section or any conceptual lecture, you can ask me in the comment section.